When you ask a modern AI a question, the response feels remarkably human. It seems to grasp your intent, your nuance, and your logic, as if it truly understands the world. This leap in technology isn't magic. It's the result of a specific software architecture introduced in 2017 called a transformer. To see how it works, imagine language is a complex scene that needs mapping out. To make sense of it, the AI acts like a detective, organizing connections on a giant corkboard. Older systems struggled because they looked at one detail at a time. They read words in a strict sequence, completely blind to the surrounding words that give a sentence its meaning. If a machine only sees the word bank, it gets stuck. Without seeing the rest of the sentence, it has no way of knowing if you mean a place to keep your money or the muddy edge of a river. To solve this, a computer needs a way to look at every word in a sentence at the exact same time, measuring how every part relates to every other part. Since machines can't actually read, the first step is to translate text into numbers. We use a neural network to turn every word into a set of mathematical coordinates. This creates a map where words with similar meanings cluster together. Because great and awesome are often used in the same way, the computer gives them coordinates that sit very close to each other on the map. However, a word's position is just as important as its definition. The dog bit the man and the man bit the dog use the same coordinates but tell a very different story. To fix this, the transformer adds a unique numerical stamp to every word, locking its exact place in the sequence. By combining the word's location on the map with its position in the sentence, the AI now has an organized grid of data ready to be analyzed. Now, the transformer uses its most important tool to find the context: attention cells. This is where our detective starts pinning red threads across the corkboard to connect related parts of the sentence. Take the sentence, "The pizza came out of the oven and it was delicious." To understand what "it" refers to, the attention cell calculates a relationship score between it and every other word. Since delicious usually describes food, the connection to pizza glows brightly, while the link to oven remains faint. The words closest in meaning have the most influence on the final result. The transformer performs this calculation for every single word in the sentence simultaneously, weaving a massive web of connections that captures the context of the entire thought. This process allows the machine to see exactly how different parts of a sentence lean on one another, creating a digital map of how the words are actually related. Once the board is mapped out, the AI uses two different departments to handle the data: the encoder and the decoder. The encoder analyzes the entire completed web at once. This is perfect for things like translation or determining if a review is positive or negative, because it can see the big picture. The decoder, however, only looks at the words that have appeared so far. Its job is to use that context to mathematically predict what the very next word should be. While encoders power search engines and document sorting, decoders are the engines behind the text-generating chatbots we use to write poems or answer questions. To generate text, the AI runs the full cycle. It turns words into numbers, assigns their positions, and weaves those threads of context to understand your request. Here, the decoder uses the existing context web to predict the logical next word. As the word appears, the web updates to include it. This loop happens at an incredible scale, generating words so quickly it produces paragraphs in seconds. Ultimately, these chatbots aren't thinking or feeling. They are running a highly advanced probability engine, using context to determine the perfect next word to respond with.